So here we're about to begin the bomb lab. The first thing that we're going to do to begin the bomb lab is click into our terminal. And now that we're in our terminal, we're just going to start listing our commands. The first command that we're going to list is ls. And what ls stands for is list everything in your folder, or also known as directory. So as you can see, it lists a bunch of different types of folders, and these are the same folders that show up right here. And if we're trying to go into our desktop, and as you can see, the desktop folder has Bomb Lab and Hello Capstone in it. So to get into that, we're going to type in cd and the name of the folder, which is desktop. I misspelled it, so I have to capitalize the desktop. And as you can see, now that it's picking up the desktop, we're going to type in another command, which is ls. And that's going to list everything in the desktop folder. And as we saw before, we can see the Bomb Lab and the Hello Capstone pop up again. After we get those two folders, we're going to change directory to Bomb Lab. And so once again, we're going to type in ls to list what's in the Bomb Lab. Once we see what's in the Bomb Lab, it says bomb.c. Now bomb.c is going to be a list of code that we are trying to get into, and by getting into it, we're going to type in vi bomb.c. And by typing that in, we can see that list of code has been brought up to the screen. I'm going to begin explaining what these lines of code mean. The very first thing that I would like to point off would be there's two main functions in this code. One that is void bomb and the other one that is void main. And let's work our way down from top to bottom. So the very first three lines that we see are in blue. These are libraries, and they're basically like folders with pre-made functions built into them. Working our way down from that, we see void bomb and char input. What void bomb means is that there is no return from this function, and what char input means is it takes the input of what the user types in. And working ourselves down, we see something that says char password. What char password is, it's the password. We'll explain this a little bit later on. Below that, we see there is if, and what if means is if there is zero difference in the comparison of the password and what you type in, then it will be diffused. And below that, we see else, which is else if they don't match, it will blow up. And going on to the next function, this is the main function. This function actually goes first, since it's called the main function. Let's begin explaining this one. The very first thing that we see is void main, which means the same thing as the void bomb. There is no return from this function. And then below that, we see something that says printf. Printf is a pre-made function from the library that shows what's in the parentheses right here on the terminal. And below that, we see something called char string 27. This is the variable that stores the input, basically, so what you type in. And below that, we see fgets. Fgets takes the input from the keyboard and saves it into the string. And below that, we see something that says bomb, which checks if the input is the same as the password. So this, if you were actually trying to defuse a bomb, would not be what you would actually see. What you would see would be this. Just the printf, or the things that were in the printf parentheses. This is all you would see. And for example, if you were to take like a random guess at the password, you could see that you would die and it would go off. The next step to finding our password is going to be changing our source code that we were previously looking at now into assembly code. So to do that, like I said earlier in my presentation, we're going to need something called a compiler. GCC is going to be our compiler, and it needs to know what it's going to compile. So the next thing we're going to type in is bomb.c, which is our source code, so it knows that that's what it's going to want to compile. After we type that in, we're going to type in S. And what S means is that we want the output of the compiling to be assembly code. So after we type that in, we're going to type in O bomb. And what that means is what we want the output file to be called. So we're going to name our output file to be assembly.s. So now that we hit enter, we're going to type in one more command, which is going to be ls, which is list what's in that folder. And as we now see, we see underscore assembly.s, which is what we named that file right here. And like we did earlier, to access that file we just created, we're going to use vi bomb assembly.s. So now we are brought into assembly code. The first thing that you would probably notice about this assembly code is that it looks a little bit different than the assembly code that I previously had on my slides. Well, the reason for this is because I compiled this on a different computer, and different computers have different assembly languages, even though they're still using the same source code. Also, you may notice how the password is at the very top. Well, I'm going to show you, just in case this wasn't to be, how you would find the password. This is now when we're going to introduce the debugger. And the debugger is what's going to allow us to perform buffer overflow and find the password. So our debugger is going to be gdb. As you can see, when we type that in, there's some stuff that pops up. And we want to be accessing the file called bomb machine code. So, alright, so it gets that. It says it's reading the symbols from that file. And the next thing we're going to do is add breaks. And before I start adding breaks, let's just say why they're important. Breaks are they're breaks in the execution of the code, so it doesn't automatically complete. Because if the password was wrong, it would the bomb would explode. And breaks allow you to exit in time before the bomb explodes. So let's start adding a break. And B1 stands for break 1. So we see break 1 and it says line 4, and we're going to keep adding breaks in. So B2 and B3, B3, and then B4, and then all the way up to B5. Okay, and so one thing I wanted to point out was that when you compile source code into assembly code, it gets longer. So one line could be many lines, and just looking right here, you see how it keeps saying line 4, line 4, line 4. Going back to the earlier code, we look at line 4. This one line right here, one line ended up being multiple lines when broken down into machine code. Alrighty, so the next step is going to be adding in your breakpoints. I spared you guys from having to watch me add in 30 breakpoints, but as you can see, I added in 30 breakpoints. So let's just go over and start explaining why these are important. When we go back to our assembly code, we're going to see that at line 30, it's going to call for a string comparison. And this is important because what a string comparison means is it's going to compare your input for the password to the actual password. It's just checking to make sure they're the right password, basically. And the reason this is important is because we're going to make the assumption that everything from line 30 down and below is going to be responsible for the diffusion or the detonation of the bomb. So there really is no need to make breakpoints after line 30 because of the string comparison. So that is why we stop at breakpoint 30. After breakpoint 30, we type in the command run. Run is going to start our program. And once it starts our program, we see the main function, welcome to the bomb lab, defuse the bomb, or blow yourself up. Have a nice day. Enter password. So we enter in a test password. And we begin to run the program. But after every single line, we see that there's a break. And that's because we added in all of our breaks. So we have to manually continue the program by typing in C, which stands for continue. And we continue on to the next line, the next line, next line, next line, all the way up until we get right before line 30, because we know at line 30 it's going to test the password. And what we do now is we're going to check for right here, and what these are registers. And we're going to see if there's any common registers that tend to repeat themselves, anything that we believe might have the password in them. So we come up with a guess, and we say RDI seems like a register that repeats itself and could have the password in it. So we use the command print char, and this basically just shows us what's in this register right here, and after that we can see that it's the test password, the password we just previously typed in. So we say, all right, we take another guess, and we test the register RSI. When we test RSI, we see it comes up with the password, make every dog exceptional. Okay, so now the next thing we got to do is turn that into machine code. So the first thing we're going to do, first command we're going to do is ls. Ah, you motherfucker.